So let's get right to it. The situation that we're in today is we've got an unpatched Oracle vulnerability that was recently disclosed. Now this story goes back a long, long way back to 2008, when a security researcher named Yaksin Korit found this critical vulnerability in Oracle databases. Yaksin ended up selling that vulnerability to an organization that buys 0 days, and that organization reported the vulnerability to Oracle, again, way back in 2008. This has just been sitting ever since and just came to light late last week on Thursday. Now, this vulnerability affects all versions of Oracle databases, going back to Oracle 8i, all the way up to the most recent release of Oracle 11g R2. When the vulnerability details were announced on Thursday, they included a fairly complete working proof of concept exploit that my team has downloaded, tested, and verified that it does function fully as advertised. And there's no patch available for this issue. And on top of that, Oracle has no plans to produce a patch for this issue. They do say they'll fix it, but they'll be fixing it in a future database release. And we don't have any date or any visibility into when the next major database release will come out that has this fix. So we may be dealing with this 0 day out there for a very long time. Looking at this vulnerability, this is a man-in-the-middle attack. It's really classic man-in-the-middle. And what it allows an attacker to do is really to observe any interaction between a client and a database, and to hijack connections between a client and a database and inject any commands into that active session. So if an attacker is executing this attack, they have the ability to hijack a database administrator session and take complete control over an Oracle database without any authentication or access to that Oracle database. They merely need a presence on the network. When the vulnerability was found, Yaksin named it TNS poisoning. It's a pretty interesting name. TNS is the name for Oracle's network protocol. It stands for Transparent Network Substrate. And this is a vulnerability in Oracle's TNS listener component. And I'll explain a little bit about that component in a few minutes. This vulnerability is remotely exploitable without authentication and allows for a full compromise of confidentiality, integrity, and availability of data in the database. So by definition, this is a CVSS 10. This is as bad as vulnerabilities get. Although Oracle is doing their best to downplay this vulnerability and is classifying it as a CVSS 7.5, they get away with that, or at least they justify that, by saying that the operating system isn't also compromised here, and so the severity is less. We don't agree with that perspective. This is an Oracle vulnerability, has nothing to do with the operating system. It's about exposure of the database, and therefore should be classified a CVSS 10.0. As I mentioned, this impacts all versions of Oracle, so any Oracle database you're running right now is very likely to be vulnerable to this, from Oracle 8i all the way through the latest release. So we're talking about 15 years of database history here. So let me show you sort of a picture of the attack. I'll describe the components in the Oracle stack a little bit, and then we'll go through and I'll show you a demonstration of the attack, and then we'll talk about how you can work around and protect yourself. So three components in the picture so far. Starting from the left, we've got our little administrator icon. That's going to be our database administrator in this diagram. In the middle, we've got Oracle's TNS listener. And then on the right side, we've got an Oracle database. That's probably a good time to explain the listener. The architecture of Oracle, it requires this component called the listener on the network. And when you make a connection to an Oracle database, you actually connect to the listener. That listener has a registry of databases that it's listening for. And then once you make a request for one of those databases, the listener passes you off to communicate with one of the databases. So it looks a lot like this. The client makes a request to the listener. The listener comes back and says, the database you're looking for is located here. And then the client starts communicating directly with the database. This is the typical sort of Oracle connection that you see out there, Oracle network connection. Now, where this attack comes in requires obviously an attacker, and that attacker sets up a proxy. So a proxy is a system that simply passes traffic through it and has the ability to record potentially that traffic. So what happens with this attack is that the attacker is able to poison the listener. And it's able to poison the listener by dynamically registering a new database with the listener. That dynamic registration process happens without any authentication. So anybody on the network can effectively register new databases with an Oracle listener. Now the listener has some special features. If you register a new database with a listener that's got the same name as a database that's already been registered with that listener. So say I've got a listener that's listening for a database named Josh. If I now register a new database named Josh with that same listener, the listener will assume that I'm in a cluster and it needs to load balance. And so what it'll start to do is every connection, it'll just simply make a load balancing decision, a round-robin load balancing decision, about which one of the registered databases to send that connection request to. So now the picture looks like this. The client requests a connection from the listener. The listener comes back and points the client to the proxy instead of directly to the database. Now since it's a proxy, the proxy is actually going to, the attacker proxy will be set up to proxy any connections that come in back over to the real database. So the idea here is that the client that's making the database connection has no idea, can't see anything different happening in their usage of the database. But as you can see from the diagram, that attacker is kind of sitting right in the middle, owning that proxy server, able to observe anything that goes back and forth between the client and the database. The attack doesn't end there, though. With this proxy, I can take control over this user's session. So perhaps I'd configure the proxy to wait for the user to close their connection, but I wouldn't proxy that close command over to Oracle. Instead, at that point, I would take ownership of their connection and start running commands. Now, if I have a database administrator user that's connected to the database, I'll be able to run commands as that database administrator like this. And at that point, I have complete ownership of the database and all the data within it. So this is basically how the attack works. We poison the listener to route some traffic through a proxy to the database. That happens transparently to the users, and once it does happen, the attacker has full control. So let's actually look at this attack happening. I'm going to attack an Oracle 11G Release 2 database running on Windows. And so on this screen, I've just got the Windows interface configuration. My database server that I'm going to attack is on this IP address, 192.168.0.193. So remember that number. That's going to be our target database. This is the system we're going to attack. Now, when you see a blue background, that's going to be our Oracle client machine. So here's our DBA making a connection to the database. And what you see is at the top, he's using SQL+. SQL+ is Oracle's ad hoc query tool. Logging into the database is a user called system. And you can see the password there, that's /syspass123. That syspass123 is the user's password. And then you see the database being identified, the IP address 192.168.0.193, and then the database name, which in this case is ORCLDB, Oracle DB. The DBA makes this connection to the database, and then from there can run privileged commands. So the DBA can read sensitive data, for example, select name and password from sys.user$, where the name equals sys. What this little command will do is pull back the username and password hash for the sys user in Oracle. The sys user is the most powerful user in the Oracle database. It's root for Oracle. So this is a highly privileged command that only a DBA can run. Now when you see a red background, that's going to be our attacker system. So in the attacker system, the first thing we're going to do is we're going to start up the TNS proxy. So TNS proxy is a really, really simple thing to write. In this case, we've got one that's written in Python. And it takes a few arguments. It takes a local IP address and port and a remote IP address and port. So note that the remote IP address and port is the same IP address as the target database. what this proxy is going to do is proxy any connections that come locally to 192.168.0.168. That's the attacker machine. And proxy those connections over to 192.168.0.193. That's the database that we're attacking. A very simple proxy. It'll proxy these connections. And in the meantime, any data that flows across the proxy, this Python script will dump to the screen. So we've got a proxy running here. Now, once you've got the proxy running, the next step is to register our new database for our proxy with the listener. So to do that, it requires some hand editing, some manual packet creation, and this is the proof of concept exploit code that Joachim provided in his post. What you can see here is obviously a bunch of hexadecimal, but if you look inside that hex, you'll notice the ORCLDB identifier. This set of packets is registering a new database called ORCLDB, and you see that pattern a few times in this text here, with this listener. Back to the client machine. So again, here's our DBA. And the DBA is once again going to make a connection to the same database. So just like before, uses SQL+, same user ID, same password, same IP address and database identifier. And no wonder he gets the same response. And when he goes and runs, again, that same read of sensitive data, gets the same data back from the database. Nothing's changed from the client machine. Things look exactly the same. The attack is currently in place, but as I mentioned, this is totally transparent to the users of the database. Back to the attacker system. So once that query is run, once that connection happens and that query is run, this Python script really starts to dump a lot of data to the screen. And I've highlighted in yellow some really important stuff that we caught in the proxy. Notice the SQL statement. We see the raw SQL text that was executed against the database. Select name password from sys.user$, where name equals sys. And then you can see down below, the next piece we highlighted, we see the name sys, and then we see the password hash being returned from the database. So here's the data, here's the request going to the database and the response coming back. And if you kind of look in this hexadecimal, you'll see in here the word name, you'll see the word password. And if I go back one screen, again, you'll see what came out of this query, name sys, and the password, and here's the password hash. So again, we're seeing the raw data flowing across the network here, just being printed to the screen with our proxy. I don't know that I have to say this, but this is bad. There's a little bit of light at the end of the tunnel here. Despite the fact that there's no patch and no patch coming, there are some workarounds. If you're running on a standalone deployment of Oracle, meaning you're not clustered, the workaround is fairly easy. This registering of databases with the TNS listener is actually something you can turn off. You can disable dynamic registration of databases by setting the listener setting, dynamic registration equals off in the file listener.aura. And once you make that change, you need to restart the listener. You do not need to restart the database. And it will no longer accept dynamic registrations of databases. And that'll just shut this attack right down. However, this is not an option for folks that are running RAC clusters. And Oracle RAC is a really, really popular clustering solution out there for Oracle databases. Really the only way to deal with this problem if you're running a RAC is to use strong authentication before you allow anybody to talk to the Oracle components. Now, Oracle's got an add-on package for that. It's called ASO, or the Advanced Security Option. It's been in the past something that Oracle's charged a pretty penny for, but because they're stuck in this situation, they've changed the license model and they've made Oracle ASO free for everybody who's licensed to use RAC. So if you are using a RAC, the solution here is to implement ASO, to require SSL, and what that'll do is by using certificates to authenticate everybody that's going to talk to the database, only legitimate components that have been given a certificate will be able to talk to the listener and register databases. Now this one is much harder to implement because it does require modifying every client in the environment both to add the certificate to the client to authenticate to the database, as well as potentially configure the client to request or require SSL encryption. Now, it's most important that the database requires SSL. But if you have a client that won't use encryption, it won't be able to connect to the database anymore. So you may need to go modify the client config in addition to putting the certificates, generating and putting the certificates on each client. If you're in a rack, it's safe to say it's going to take you a little bit of time to fix this. But I think it's even more important in a typical rack simply because racks hold more data, and racks tend to be more resilient, more uptime. They tend to hold the business critical systems. So action is really needed here, despite the difficulty of moving forward. So where does it leave your organization? I mean, I don't know what to say other than we're at DEFCON 1, all of us. We've got this is the worst Oracle vulnerability we've seen in a lot of years, maybe the worst we've ever seen. It's not going to be patched. It impacts every one of your Oracle databases. This is about as serious a situation as we can get to. We can help, though. AppSec can help, and beyond the information we've provided so far, there's a few things we're offering to our clients through our product. So we've got a custom policy that we've made available to help you identify how your TNS listener settings are configured. So we can go out and scan your databases and your listeners and identify all those listeners that have dynamic registration turned on and SSL turned off. So we can go out and quickly pinpoint the databases for you that are vulnerable to this using either our DB Protect or App Protective solution. We've also released a set of attack detection rules for DB Protect that will give you a real-time alert on any attempt to remotely register a TNS listener. So this will show you the TNS dynamic registration happening, give you a real-time alert, and allow you to go shut that dynamic or that registered listener down before somebody's able to really take over your database. And of course, we're here to offer advice, we're here to offer guidance, we're here to offer security intelligence, and our teamshatter.com website's got a very detailed write-up about this vulnerability, and it includes links back to the original researchers posting, the proof of concept exploit code, and everything you could want to know about the issue, how it was found, and how to deal with it. So if you're not familiar with App Protective Pro, I'll give you a little picture of what it looks like to go through this process. Here we've got an Oracle 11G database that we found on the network. We know 11G is vulnerable. All versions are vulnerable. So once we find this database, we can run a scan, and we've got a new policy that we've released. It's called Alert Team Shatter Oracle TNS Poisoning Policy. You can download that from our customer support portal. Run the audit with that policy, and you'll get results. So here's one potential result set. Here we've got dynamic registration turned on. However, we've got SSL turned on as well. So this is a system that's not vulnerable. Here we've got the configuration we're looking for a typical rack environment. Here, however, we've got a different picture. Here we've got a system that's just got dynamic listener registration enabled, but does not have SSL turned on. So this parameter allows for the database instances to be registered. This is a vulnerable system. This type of scan will take approximately 60 seconds against each of your databases. So it's very, very quick. And if you've got thousands of databases out there, you can kick off this scan, you can go out to lunch and come back, and you can have an answer on all of your databases, whether you're vulnerable or not. Now this picture is from DB Protect. Here's what it will look like when you implement our dynamic registration rule set. So here we see, and I know it's a little bit of an eye chart, but here we see a couple of real-time alerts coming in as listeners are remotely registered. And we can see sort of in the detail that here we've got dynamic registration on the TNS listener. This is a possible TNS poisoning attack. We're not sure that it's a TNS poisoning attack. This may be a legitimate rack doing its dynamic registration. At this point, it's impossible to discern between the two. But we can give you the ability to immediately investigate any dynamic registration that happens in the environment, track it down, make sure it's legitimate, and if it's not legitimate, shut down that potential proxy before it becomes a problem. So as I mentioned, you can go get this, both the policy for scanning as well as the rules for monitoring from our customer support portal. So that's appsecinc.com/support/customer portal. Those of you who use the software, I'm sure know that link fairly well. So just log in and then navigate through downloads to product downloads, and you'll see the zero-day references. Just click on that link, and you'll see both the scanning and the monitoring the feeds to help you identify and mitigate the risk around this vulnerability. So as I mentioned, this one is bad. This is really the most severe Oracle vulnerability we've seen in a long time. But you can protect yourself immediately. We'd be happy to help you. I urge you not to hesitate to act and to start moving forward to remediate this issue. If you're storing critical business data in your Oracle databases, and you really want to make sure that that data is only accessed by people who are authorized to access it, then this is something that you really need to deal with right away. So that's all I've got for the presentation today. Very, very brief. We've got plenty of time. I'll open the floor to questions. We can take some questions and hopefully answer anything that you guys have got. All right, so I'm going to open up the questions, and I'll just start walking through them. The first question comes from Boris. Boris asks, a certain document that Oracle published talks about 2 methods. Which one should you choose? So Boris, it depends on whether you're running RAC or not. If you're not running RAC, you should disable dynamic registration. That's the easy thing. If you are running RAC, then you need to implement ASO, you need to turn on SSL, and you need to require SSL for all connections to the database server. Now, the second question also came in from Boris, and he asked about a patch. Oracle did not issue a patch for this vulnerability. Oracle issued a security alert. That security alert simply documented the workarounds that I've just discussed. Those workarounds were originally put out there by Joachim Koret, the vulnerability researcher that found them, but Oracle did put some more details around that and some more step-by-step guidance. So again, that guidance tells you to either disable dynamic registration or to use SSL. If you're running RAC, you really need to use SSL.
Josh, while you're looking at the next questions, we do have a question that we tend to get all the time on the availability of this webinar in terms of it being recorded. This webinar is being recorded. We will distribute a link within the next 24 to 48 hours so that if there's something that you missed and you want to recheck it out, please watch the recording, or maybe you might have a colleague that you want to forward this along to that may have missed the session. So look for that link within about 24 to 48 hours.
Thanks, Jeff. So the next question we got comes from Kevin, and Kevin asks about an instance of Oracle 11.203 running ASM. That's their advanced automated storage management, and the listener running off the grid home. So Kevin's asking if dynamic registration off works for single instance ASMs databases. So my understanding, Kevin, is that it does. That ASM is simply managing your disks and has nothing to do with anything related to the listener or listener registration. So you should be able to, on single instance deployments, disable dynamic registration. But if you do have RAC, then you cannot. Although if it's a single instance RAC, and I almost never ever see a single instance RAC, and you're never going to change that beyond that single instance, then you should be able to disable dynamic registration. Although I'll tell you that's something that we haven't run into and haven't tried. The next question comes from Mike. Mike asks if using ASO and SSL requires changes to all of the apps in the environment. It doesn't require any app level changes, Mike. So what ASO is really client level, but it does require you to do things to your app servers in order for them to be able to connect to the database. And the things you need to do, first and foremost, is install the certificate that'll be able to authenticate against the database using SSL. And then you need to make sure that that client it supports an encrypted SSL connection with the database. So you won't have to go in and change any app code, but you will very likely need to change some configuration on your app servers. So I got a couple of requests to show slide number 12 again. So let me go back and see if we can find slide number 12. Oh, slide number 12. Well, slide number 12 doesn't say so much. Just that we really think you ought to be worried about this, and this is a 0-day and one that affects all your Oracle databases. So we just want to call attention to it and let you know that if you're ever at a DEFCON 1 high risk situation, this vulnerability certainly puts you there if you're storing a lot of critical data in Oracle. Okay. So the next question comes from Robert. Robert asks about the Oracle security alert that came out and what we think of the solution that Oracle's detailed there. We think that's exactly the same solution that Joachim, the researcher, put out at first, and it's the same conclusions that our research team came to. So we believe that the approach that's been documented, which includes either disabling dynamic registration or using ASO and SSL, are the only viable approaches right now to solving this problem. I do hear some talk about using Oracle's valid node checking to limit the clients that can connect to the system. I do not recommend using valid node checking. Valid node checking has got two real issues there. Issue number one, any valid node can issue this attack. Issue number two, valid node checking is an IP address-based filtering protocol, and IP addresses are just so imminently spoofable that I just wouldn't ever trust valid node checking to really protect me from an issue this severe. So I wouldn't use valid node checking on this one, even if you see some guidance about that. I'd really stick to either dynamic registration, disabling that, or moving to SSL. Marcel asks if a static SID list for a listener will resolve this issue. It sure will, Marcel. The only problem is if you're running RAC, the RAC instances do tend to dynamically re-register. So with RAC, you may be able to configure a static SID list, depending on how you've set up your cluster, and I think you probably know that best. Just be sure that nothing changes in that cluster such that any of the nodes need to re-register, and you can probably turn off dynamic registration. But that's something that Oracle's not advocating right now. And it's something I haven't seen anybody try, but from a logical perspective, that makes sense and it should work. Marcel also asks if symmetric encryption will mitigate the vulnerability. Encryption won't do anything to mitigate this vulnerability. The only thing that's really going to help here is strong authentication. So SSL is usually thought of as an encryption protocol, and it does do encryption. But the reason for using SSL here is because of the certificate-based authentication. That'll keep anybody that hasn't been issued a certificate to connect to this database from ever being able to talk to the listener and attempt to dynamically register a new instance. A lot of questions. Marcel also asks if Oracle Connection Manager will mitigate this vulnerability. That's a good question, and it's one I don't have an answer to, Marcel. If you've got Connection Manager set up and you've removed the listener from the environment, I suppose it should it should eliminate the problem. But it's something that I'm not sure of. Akbar asks if we need to disable static registration by removing the SID list parameter from listener.aura. Akbar, you do not need to remove the SID list parameter from listener.aura. The SID list parameter is static registration is good and not vulnerable to this attack. Daryl asks about Oracle Failsafe. Daryl, I've never even heard of Oracle Failsafe. So I don't have an answer for you on that one. I will jot this down and get back to you if I can get if I get any information on Oracle Failsafe. I mean, they've got so many products. That's one that I'm not familiar with. Andy talks about Oracle not recommending dynamic registration, but instead changing the protocol to IPC. Changing the protocol to IPC would would effectively disable your ability to connect to the database across the network. That's great if you don't need to connect to the database across the network, but I don't think it's going to help you if you do need to keep that database network connected. Joseph asks what the role of the remote listener parameter is, and can this be a parameter that can be used as a workaround? The remote listener parameter cannot be used as a workaround. The idea is that this vulnerability does exploit remote listeners, so my proxy is using a remote listener in order to get to hijack these sessions. So I'm going to set up a remote listener on my attacker system, effectively pointing to the target listener, and that's going to pass stuff back through to me. So a remote listener, there's no way to use that as a workaround for the issue. Andy asks if there's any way to mitigate this without using listener.aura files. Andy, I don't know how to manage a listener without using listener.aura files. Listener commands just write to listener.aura files, and typically we see all listener commands disabled such that you have to manage the listener through listener.aura. So I'm not sure what you're doing there, Andy, but if you want to follow up on this discussion, you can certainly shoot me a note. I'm josh@appsecinc.com, and we can dig into it together. Next question comes from another Josh, good name. Josh asks, what if all connections coming to the standalone or rack system are only allowed through an IPsec VPN tunnel, SSL VPN, or only through a private network? Is it still big of a risk? Well, the risk here, IPsec VPNs, SSL VPNs, I mean, that's a great way to control access to a network. Well, the question you've really got to ask is that everybody who can you guarantee that everybody who has access through that VPN is trusted? And I think if you're answering that yes, you're probably misleading yourself. It's just so easy for attackers to get on your network. If you don't operate with the mindset that attackers are on my network today and they'll always be on my network forever and I need to deal with them there, then I think you're really leaving yourself up to some pretty tremendous risk. So while using an IPsec VPN tunnel or an SSL VPN tunnel is a great way to limit who can get on the network and who can get to the databases, you still need to be worried that one of those trusted users may have had their system hijacked by an attacker through malware, drive-by download, so on and so forth, that's now got legitimate access through the IPsec VPN and can set this right up. So that's something I'd be concerned about. Yu Ming asks if Oracle selects some different workarounds. There are some more details that Oracle gives, and again, Yu Ming, you mentioned the IPC setting there. I still believe that, like I mentioned earlier, that it gives us some. It may give us some protection if we set the secure register listener to IPC, which would mean you can only register listeners locally. But again, that's only going to work if you've got a local system dynamically registering listeners. If you've got rack on a network, I don't know how that's going to work for you. Ben asks if the TNS lister logs dynamic registrations as part of a normal deployment. Then it depends on the version of Oracle that you're running. The newer versions do have some information in the listener log, but most versions do not. So this is a really tough thing to detect by using Oracle's native logging capabilities. It's one of the reasons why we went out and very quickly built a real-time monitoring rule to detect these registrations. Paul asks, where is it documented that ASO is now free with rack? That's part of Oracle's security alert document. I believe the document number is 1453883.1, but that's something you can certainly look up. We've got a number of questions coming in about using class of secure transport. Unfortunately, it's another feature that I'm not terribly familiar with, and I'm not sure how it impacts this vulnerability. I don't believe a lot of folks are using it, but it sure seems like some folks on the call are. So I apologize. I don't have an answer for you. For those of you who are asking me about cost, There's a question from Kevin about how this impacts data guard switch over and switch back when you alter the remote listener information. I don't believe there's any impact on data guard, Kevin. Marcel asks if all of ASO is free with RAC. Marcel, I can't speak for Oracle on that one. My understanding is that they've given an ASO license out to anybody using RAC. I haven't seen anything where I've read that they're limiting the functionality of that, but it's always about reading the fine print with Oracle, and I have not read that fine print. And I don't know if I've missed any. There was a big list of questions, but I think that's about it. So if I missed anybody's questions, I do apologize. Please feel free to send either me an email directly, josh@appsecinc.com. Send us an email to sort of our general reflector. We've got let me go back to the last slide here. We do have a sales@appsecinc.com email that you can send stuff to. I promise if you send us technical questions, we won't come back with please buy our product, at least not right away. We'll help you to answer them. And use teamshatter.com is a great resource. We try to put everything that we can publicly disclose up on teamshatter.com. We try to provide links out to everybody else that's giving some good insight. So that'll be a great source of information for you. I thank everybody for joining us today. A lot of great questions. I know this is a really hot topic. And if there's anything that Application Security Incorporated can do to help you, please don't hesitate to contact us.